Hi, my dear friends, myself Naveen Kumar Saini. In the course Electromagnetic Field Theory, in the last lecture we have started the gradient, divergence and the curl. These concepts we have started, and after these three we have taken care of about the gradient and divergence in the previous lecture. So I will suggest please go through the previous lecture in which we have covered these two topics, and next is the Stokes theorem and along with it the curl. So first of all, before understanding the theorem, Stokes theorem, we must know what is the definition of the curl. So when we say curl means nothing but the rotation, right? So just like in the divergence theorem, we said the point source emanate the energy or emanate the electric field. So similar to that, we have the curl of any vector. So resultant will be the vector itself, and that vector, the magnitude and the direction. So it will help to rotate the vectors, right? So by the definition of the curl of A is axial or rotational vector whose magnitude is the maximum circulation of A per unit area as the area tends to 0. So in the divergence theorem, if you remember, where we said in the case of divergence, where the volume tends to 0, right? So when the volume tends to 0 or the per unit volume, so in that way we derive the divergence and the divergence theorem. Similar to that, in the case of curl, when the area tends to 0, okay, or for the per unit area, we say what is the direction of the vector or the maximum circulation of the vector. So in this, the direction is the direction of that vector will be the normal direction of the per unit area. If this is the surface, so the direction of the curl will be what? Perpendicular to this surface, and this surface shrinks to the point, right? So by in the mathematical expression, curl of A will equal to del cross A is equal to limit delta S tends to 0 and A dot dl. This is a closed path. So this is the closed path is equivalent to the open surface, and here delta S we divide with the delta S, and that is, and then the direction is involved in that is the AN. So as I said, the direction of curl will be the perpendicular to the surface, and this surface shrinks to the unit area, right? So in this, as we said, the physical significance of the curl is nothing but this is the rotation. If there is a curl, then this is the representation of the curl of any point P of which is out of the page, right? The direction of this one is the out of the page. And second case is when at the point P there is no curl. It means if there is no curl, it means there is no rotational vector. So these things must be clear to all of you. What is the definition? What is the definition of the curl? So these are the vector representations of curl in the different coordinate systems. Del cross of A in the Cartesian coordinate system, cylindrical coordinate system and the spherical coordinate system. So based on that, you can try the numericals. It will help you to understand how to put the values of Ax, Ay, Az in the Cartesian coordinate, A rho, A phi, Az in the cylindrical coordinate, and Ar, A theta and the A phi in the spherical coordinate system. So there are some of the identity based on the curl and the divergence. In the last lecture, as we discussed about the divergence, so in that, if the divergence of any vector is 0, so in that case we say this vector field A is said to be the solenoidal. Okay, so this vector is said to be the solenoidal or the divergenceless vector. If there is del dot A is equal to some value, so we will say this is the there is a divergence is involved. So it may be the positive divergence or the negative divergence. If it is 0, then this quantity is the divergenceless. Similar to that, when we have the vector field and we are taking the curl of that vector field, and if we are getting the value is 0, so this is the representation of the e-rotational vector. Okay, so in this case this is the e-rotational. Suppose value del cross A is not 0. So in this case, if del cross A is not 0, so this is the case of the rotational. So it means the rotation is there. It means the rotation is there, right? So this identity will help us when we will talk in the unit 5, that is a wave equations. Okay. Next is the Stokes theorem. So this Stokes theorem simply relate the closed path with the open surface, right? So as in the divergence theorem, as we have discussed, the closed surface is equivalent to the volume, and here in the Stokes theorem, this in this Stokes theorem, del dot A with the closed path is equal to the curl of that vector with the open surface. So what it says, Stokes theorem, that the circulation of vector field A around a closed path L is equal to the surface integral of the curl of A over the open surface, This is very important, which is bounded by the path L and provided by vector A, and del cross A are continuous on the surface. So very simple, it is representing here. If this is the path, right? So this is representing the path L, and this path is closed path, and this closed path creates the open surface. So this creates the open surface. So in that case, the open surface means the direction will be involved in that. So direction of this open surface will be the perpendicular to the surface. Okay. So simply what it says, when any vector field is passing through this surface, that is equivalent to the curl of that vector field, right? So this is very important. So there is a proof of this Stokes theorem. Okay. So just remember that when we have the closed path, that is equivalent to the open surface. Okay. So in the Stokes theorem, when we go for it, what we will do, so first of all we will consider any of the surface. So we are just simply taking this surface. Okay. So this is our surface whose length is like this. Okay. So for representation, just like we have taken this path, and this is the open surface, So here we are taking the one of the section from there. So in this is the path, and this is closed path equivalent to the open surface. So we are bifurcating this complete surface into small we divide it into small cells, right? So this representation is like this one. So here this is the path, outer boundary, or this will becomes the surface. So what we are doing, the surface S is divided into the large number of the cells, which is given into the figure as well. If the kth cell has a surface, delta Sk. Okay. Suppose this is my path, right? This is my kth cell. This is a kth cell. So this is what? This is our closed surface, a closed path, and this is what? Open surface, right? This is the open surface. So in this case, what you can see, if you are taking the circulation and you are taking the circulation into the circular path, right, in the anti-clockwise direction. So you can see, if this is the path like this, so in this you can see this is like this one. For this path, this is like this, this is like this, this is like this one, right? Now if you are taking this into the consideration to a second surface, so what will happen, this is the direction of the circulation of this one, and this is that surface, this is that surface, this is this is that surface, and this is into the surface in the direction of anti-clockwise direction. Okay. So you can see here, so these two directions are cancelling to each other. Similar to that, one more example we can see. If you are taking this one to the circulation, so direction of this one is this one, direction of this one is this one, direction of this one is this one, and in this way. Again you can take another example for this one. Take this circulation, this is in this way, this is in this way, this direction is this direction is this direction is this one. So what it says, these two directions within the surface, within the closed path, will cancel to each other. This will cancel to each other, this will cancel to each other, this will cancel to each other, and similar to that for this case, this will cancel to each other, this one cancel to each other. So in this case, this one cancel to each other, this one cancel, this will cancel, like that. So if you will see very closely, you will see that the outer boundary, you just see the outer boundary. So this outer boundary direction is same, but inside the surface, when we have taken the small chunks of the surfaces, so these directions will cancel out to each other within the boundary. So we can say there is a cancellation on every interior path, right? So the sum of the line integrals around the AKGEC is the same as the line integral around the bounding curve L. Okay, so this is a simple explanation for this case when we talk about the proof of the Stokes theorem. So in this case, in mathematical order, we can understand that we are just taking the left hand side of the Stokes theorem, where we will say the closed path of the circulation of the vector A is equal to A dot dl is equal to, we are just simply adding all these paths. So we are adding all these paths, right? So we are adding this one. So when we add this, so this is a summation because this is a discrete summation. So A dot dl path Lk, that is equal to summation, and we are just simply dividing and multiplying with the delta Sk. So we are just simply dividing and multiply with it. So in this case, just simply taking the limits of the right hand side, this one of the equation by Sk, and incorporate in that delta S tends to, limit delta S tends to 0. So because what we want here, what we are taking the limit delta Sk tends to 0. Okay, so when we are taking this limit, so in this case, with these limits, this is the curl of the vector, right? So when you are taking the summation of that one, so in this case, this is completely equivalent to the del cross of A into ds. Okay, so this is nothing but the Stokes theorem. I hope this point is very much clear to all of you. So this is coming from the definition of the curl. If you don't remember, please go back. So it will help you to understand. So that is the A dot dl divided by delta S, limit delta S tends to 0. So with this, this is equivalent to the curl of A. Okay, so same thing is written here. So this is A dot dl delta S, this tends to 0, and this is delta Sk. So this representing the del cross of A into ds. One of the problem we can go through that in that vector A is there, and what we want to calculate the A dot dl with the closed path. Okay, so for that the one surface is given. So this is the path. First of all, this is the path A to B, B to C, C to D, and D to A. So we have to find the circulation, and circulation can be find out by calculating the A dot dl with the closed path. Okay, so this is the complete circulation. So we first of all we have to evaluate this A dot dl, then we will confirm it with the Stokes theorem. So for this case, we will take A dot A from A to B path, then B to C, C to D, and D to A. We will combine all these paths and we will add on. So after that we will get the result of that. So as we can see that A dot dl is equal to A to B, B to C, C to D, and D to A into A dot dl. So in the previous case, A to B, B to C, C to D, D to A. Okay, so we are taking this and we are just using this term that in this way A dot B to A to B to C, D to A for the complete circulation. So for that, first of all, what we want to know, A dot dl, right? A is given, dl is required. And when we talk about in this case, because the angles are given, so we will take the path from A to B, and in this we will take the coordinate system of spherical coordinate system. So spherical coordinate system, as we are aware, rho, phi, and z, and corresponding to that the d rho, these are elements, rho d phi and the dz. Okay, so these three are the differential elements, and we want to calculate dl. So for this case, dl will be what? DL will be d rho a rho plus rho d phi a phi plus dz az. Okay, so simply we can represent this. This is the point, this is the differential elements, and this is the differential length, right? So these things you have to take care of, right? So this equation. So as we are talking about the a to b, I will take the one of the example. A to b, what is constant when we are moving a to b? So it means a to b, and first another thing is important, x, it is moving into the x and y. So these two are the axes, and we are moving from a to b. So for this case, what is constant, what is variable? So from a to b, phi is variable, right? Rho is variable or not, and the z is constant or not. Okay, rho, phi and z. So if it is a surface, then in that case we have to take care of two variables. If we have the volume, three variables we have to take care of. If we have the length, only one variable will be there. So see, if you are moving a to b, it means the rho is constant, because rho is same from 0 to a and 0 to b. Phi is variable from a to b, because this angle is from 60 to 30 degree, and then z is constant because this surface is lying on the z is equal to 0. Okay, so z is also constant. So in this case, first case, we can see rho value is 2, which is constant, and dl is rho d phi a phi. So because this d phi, you can see in this so this is the rho d phi, this will become 0, this will become 0. So what will the value of dl? dl will be rho d phi and a phi. So here the same thing is here, rho d phi a phi. So simply you have to take care of a dot dl, a to b. Phi is 60 degree to 30 degree, rho sin phi d phi, because we have taken the value a dot dl. So when you solve, then expression you will get the minus and root 3 minus 1. So this is very important. If you understood this a to b, then rest are easy. B to c. So for that b to c, so if you go back, b to c, what is constant? Phi is constant. So this phi value is constant from b to c length. Rho is also rho is varying from b to c. So what is the value at the b? This is a 2 up to 5. So rho will vary from 2 to 5 for this case. Now go back c to d. What will variable and what is constant? From c to d, phi is varying, rho is constant, z is always be constant, because this path or surface is lying on the z is equal to 0. So z will always be 0 for this case, right? So rho from this one to this one, phi is varying and rho is constant, and d to a, rho is varying from 5, rho is equal to 5 to rho is equal to 2, right? So d to a, rho will be 5 to a, but phi is constant. For the phi value, this is a 60 degree. Okay, so if you understood this point, so just go come back here, along BC, because BC was this one for this case, right? So this was the A, B, C and D. So we are talking about the BC. So for this BC, this was the 2, this was 5, and this is 30, and this is the 60 degree. Okay, so this was the x direction, this was the y direction. So B to C, what is constant? Phi is constant 30 degree, rho is varying from rho is equal to 2 to rho is equal to 5. So this is mentioned here. Simply solve it, then you will get this expression. Now come to the C to D. So for C to D, rho is phi, dl is rho d phi a phi. So just take this expression, E dot dl, phi is equal to 30 degree to 60 degree, rho sin phi d phi. So I am assuming that you are aware how to calculate the dot products, right? So you have to practice this type of questions, getting the dot product, cross products, gradients, these three basic definitions, and the equation, how to solve this type of small problems. You have to be very much familiar with it, then only you will understand all these things, right? So I am assuming that you can solve that A dot dl. Simply a value is given, dl is already we are finding out, and we are just mentioning the limits for that. Okay, so in this case we are getting the 5 by 2 root 3 minus 1. So next is D2A. So for this D2A, if you forget, then again I will repeat, this is X. All the time you have to draw these diagrams, right? So then only you will get the, you can practice easily. This is the A, B, C and D. So this is the circulation which we are talking about. Okay, so this is was 2, this was 5, this is 30, this is 30 and this one is the 60 degree. So we are talking about the D2A. So this is the last segment, that is D2A, from this one to this one. So from D2A, the angle of this one is 60 degree, which is fixed, and rho is varying. So rho is varying from 5 to 2. Okay, so rho is varying 5 to 2. So because this direction is in this way, this is the direction. So rho is equal to 5 to 2. So just take the A dot dl, and when you will solve this by applying the limits, so you will get the value minus 21 by 4. Okay, so just simply now add on all these segments, from segments A to B, B to C, C to D, D to A, all the 4 segments simply add on, and after addition of these segments you will get the complete circulation. Okay, so this is nothing but the circulation. Most of the time this type of questions comes into your exam, so very important. As I said, if you do not know about the calculation of gradient, divergence and the curl, it's very tough to solve this type of problems, right? So I request, please all of you go through it, this is very important. And these dl, ds and dv, these are the differential, by using the differential lengths we can find the dl value, ds and the dv. These are very basics which you have to go through. Okay, so A dot dl, so when you solve this, then result you will get the 4.941. So this is the circulation value of the all the four segments which we are talking about. Okay, so now as we have discussed in the divergence theorem, to prove the divergence theorem we have calculated the del dot A. Here in the Stokes theorem we will calculate the del cross of A. So for that, del cross of A is very important to know, and ds, as I said, there are 3 differential elements, d rho, d phi and dz. So if we talk again, d rho, rho d phi and dz, and I said z is constant for this case, so in this will become 0, simple. So what left? D rho and rho d phi. So d rho and rho d phi, and the direction of this one will be az, simple, az. So just take the del cross of A, simply write these expressions and just put all together the surfaces. Z is constant, as I said, limits you are aware, rho is 0 to pi and phi is 30 degree to 60 degree, and just solve this one, and the resultant which you will get the 4.941. So which is same as we have discussed about in the first case. So I hope this point is clear to all of you. Please go through it. One of the questions definitely come in the exams, like in divergence theorem and the Stokes theorem, proof of that one and the numerical based on these two. So that is why I have just simply taken the example from here. Okay, so we will start the unit 2 in the next lecture. Thank you very much.